All right, for this video lesson, we're going to do some geometric applications of max and min problems, okay? Calculus will allow us to provide a faster means of solving geometric problems as opposed to just doing multiple cases of trial and error, essentially, okay? So using area and volume for calculations regarding those two measurements, we can use calculus to solve for unknowns, okay? So for our first example, we're asked to find the dimensions of a rectangle if the perimeter is 28 centimeters. So let's write that down. Perimeter is 28 centimeters. And the area is a maximum, okay? So for a rectangle, we're gonna have two lengths and also two widths. Right? And we also we're asked to find area. So we know area of a rectangle is equal to length times the width. Okay, so we know the perimeter is 28 centimeters. So let's go ahead and start there. So perimeter for a rectangle or for any four-sided shape is going to be the two sides plus the two width. Okay, so perimeter is 2 length plus 2 width. Okay, we're also going to go ahead and use X's and Y's instead of L's and W's. That is totally fine if you'd prefer to use X's and W's, but I'm going to use X's and Y's, just a little bit more familiar for us, okay? So length is X and width is Y, okay? And we also know our perimeter is 28 centimeters, so we can rewrite this equation here as 28 is equal to 2x plus 2y. Okay, at this point, let's write this so our variable is x. So let's write this equation in terms of y. So we will subtract 2x from both sides. And divide by 2. So then we get y is equal to 28 divided by 2 is 14, and negative 2x divided by 2 is negative x. Okay, so now we have written this, so x is our only variable. Okay, so let's jump to our area formula. So area is equal to length times width. Area is equal to length is my x times width, which is my y. And we have just found that our y is equal to 14 minus x. So let's substitute that into our area formula. So area is equal to x times 14 minus x. And let's go ahead and distribute that x into the bracket. So area is equal to 14x minus x squared. Okay, so at this point here, let's go ahead and take the first derivative. So a prime is equal to 14 minus, and I'm just going to use a bracket here, minus 2x to the 1, right? So a prime is equal to 14 minus 2x. Okay, again, while we're here, we may as well take the second derivative. So a double prime is equal to just negative 2. Okay, so if we have a negative second derivative, this means we have concave down. Therefore, this is a max. Okay, so we've just confirmed that this is going to be a maximum function. Okay, so Now that we've confirmed that this is a maximum function, let's find our critical point here. So where my a prime is equal to 0. So 14 minus 2x is equal to 0. Let's solve for x. So plus 2x divided by 2. And we get 7 is equal to x. Okay, so we have a maximum point when x equals 7. Okay, so let's go ahead and find the dimensions and the maximum area. Okay, so area is equal to x times y, and our y is 14 minus x. And we know our x is equal to 7. So let's go ahead and substitute in x for 7. So a is equal to 7 multiplied by 14 minus 7. And 7 multiplied by 14 minus 7 is 49. The perimeter is in centimeters, so our area will be in centimeters squared. So that is the max area of a rectangle. Our length is equal to x, which is equal to 7 centimeters, and our width, which is equal to y, which is equal to 14 minus 7, and therefore our y is equal to 7 centimeters. Okay. Again, this is a square, so it's not necessarily a rectangle, right? But these are the dimensions in which we will have maximum area. All right. So next example, a rectangular box with 2 square ends. So sometimes it might help us to draw a picture just to visualize what is going on. Okay, a rectangular box has 2 square ends. Something like that. Okay, we are going to have, so the square ends, so that means all of these sides are the same. Same over here. So that will be x. And the length of the rectangular box will be represented by y. Okay, so there's our box. If it has a total surface area of 150 square centimeters, so surface area is 150 centimeters squared. And to find the surface area of a rectangular box, it is going to be, so this blue side plus that blue side, so surface area, and we're going to be adding the red surface area to that as well, right? Times 4 sides. Okay, so to find the surface area for one of my squares, it would be x times x. Because I have 2 of them, it is going to be 2x squared. And multiply or added, and we have 4 other sides, right? 1, 2, 3, 4, plus 4 multiplied by the height of the sides of the box, which is going to be x, multiplied by the length, which is y. Okay, so now that we have set that up, we know our surface area is 150 centimeters squared, which is equal to 2x squared plus 4xy. Okay, let's go ahead and write this. So x is our variable. So let's get y all by itself. So we'll subtract 2x squared from both sides and divide by 4x. Okay, this will leave us with y is equal to 150 minus 2x squared divided by 4x. Okay, we are looking for the dimensions of the box and to make the volume a maximum, okay? So volume maximum. For a rectangular box or a rectangular prism, the formula for volume is the height, so x, by the width times x, by the depth of it, which is y, so x times y. And we have already written our formula in terms of y here. So let's go ahead and substitute that in up here. So volume is equal to x times 150 minus 2x squared divided by 4x. Okay, we can simplify that a little bit. So volume is equal to x squared 150 minus 2x squared divided by 4x. And let's go ahead and distribute that x squared in there. So we get 150 x squared minus 2x to the 4 divided by 4x. Okay, we can simplify this a little bit. We can factor out a 2x from the top. So let's do that. So 2x out of 150 gives, out of 150x gives us 75x. And 2x out of negative 2x to the 4th will leave us with negative x to the cubed. And that is going to be divided by 4x. Okay, we can, these x's will cancel here. We can reduce 2 over 4 to 1 over 2. So let's go ahead and rewrite this again. Volume is equal to 75x minus x cubed all over 2. Okay, which we can, yeah, if you like it how it is right here, you can leave it. If you want to simplify it any further, this can expand to 75x over 2 minus x cubed over 2. Okay, so once we have simplified that, let's go ahead and find our first derivative. Okay, so v prime. So 75 over 2x derived just leaves me with 75 over 2. And negative x cubed over 2 derived will give me negative 3 over 2x squared. Okay, and while we're at it, let's find our second derivative. So v double prime, 75 over 2 is just 0. And negative 3 over 2x squared derived will leave me with negative 3x to the 1. Okay, so now let's go and find our critical values or our max min. This is where our v prime is equal to 0. So 75 over 2 minus 3 over 2x squared is equal to 0. So let's solve for x. So plus 3 over 2x squared. Those will cancel. We're left with 75 over 2 is equal to 3 over 2 x squared. Okay, let's get x by itself. So divide both sides by 3 over 2. $75 over 2 divided by 3 over 2 is 25 is equal to x squared. Take the square root of that. And we find that x is equal to 5. Okay, so we know at x equals 5, we have a max min point. So let's check the concavity by substituting that value into our v double prime, okay? And that gives us negative 15. Negative second derivative at 0.5 tells us that it opens down. So this is a maximum. Okay, so we just checked, we just double checked to make sure that we were indeed finding a maximum value. Okay, so x is equal to 5 is an important point for us. We know that is our turning point or a critical value. So let's go ahead and find our dimensions. So we know x is equal to 5. Okay, so to find my y value, I'm going to substitute that into this equation right here. So y is equal to 150 minus 2, 5 squared divided by 4 times 5. Okay, and that will give us a y value equal to 5. Okay. Again, so if our y value is 5 and our x value is 5, this is just like a big cube, right? Not necessarily a rectangular box. Okay, and so we know the dimensions. X is 5 centimeters. Y is 5 centimeters. Now let's go ahead and find the volume. Okay, so we can just substitute that into our volume formula up here. Volume is equal to x times y, which is 5 times 5 times 5. These are all in centimeters. So my volume will be 125 centimeters cubed. All right, moving on. Okay, so a farmer wishes to fence part of a rectangular field along a straight river. It is not necessarily, it's not necessary to fence the side bordering the river. Okay, so there's just a little drawing there. The area of the rectangular field is 1,800 square meters. And the farmer wishes to use the least amount of fencing material. So this is a min problem. Okay, so we are asked to find the dimensions of the field. Okay, so we know our area, so let's work off of that. Area of a rectangle is going to be length times the width, or width times height, however you want to call it. Okay, so the area here will be x times y, right? Length times width. So let's write this equation in terms of y. So we'll divide both sides by x. Now we have found y is equal to area divided by x. Okay, we also know area is 1800 divided by x. So that is y. Okay, and we're looking to find the minimum value for the perimeter. Okay, so the formula for perimeter here, perimeter is equal to 2x plus y, right? This side plus this side plus that side. We do not need to fence the length along the river. So perimeter is equal to 2x plus y. Now we have just solved for our y is 1800 divided by x. So let's substitute that into this formula. So perimeter is equal to 2x plus 1800 divided by x. Okay, let's rewrite this 1800 divided by x so it's easier for us to take the derivative of. So p is equal to 2x plus 1800 times x to the negative 1. Okay, so let's take the derivative of this. So p prime is equal to 2. That negative 1 comes down, so we have negative 1800, and we subtract 1 from the exponent, so we get x to the negative 2. Okay, and while we're at it, let's take the second derivative. So derivative of 2 is nothing, and then the derivative of negative 1800 x to the negative 2 will give me positive 3600 x to the negative 3, which we can rewrite as okay. So now that we've taken the first and second derivative, let's solve for when our first derivative is equal to 0. Okay, before we do that, it's probably going to be easier just to rewrite our first derivative. So p prime is equal to 2 minus 1800. And this is going to be brackets divided by x squared. Okay, so we are solving for when p prime is equal to 0. So 0 is equal to 2 minus 1800 divided by x squared. We'll add 1800 divided by x squared to both sides. That will cancel. Okay, so we're left with 1800 over x squared is equal to 2. Multiply both sides by x squared. Divided by 2. 1800 divided by 2 is 900 is equal to x squared. And we take the square root of that. X is equal to 30. So we know when x is equal to 30, we have a turning point. Okay, so let's go back to our second derivative just to make sure that we do indeed have a minimum value, right? So we'll substitute our turning point here into our p double prime. So 3,600 divided by 30 cubed will give me a positive answer. Okay, which means that it will be therefore positive at x equals 30. Therefore, this is a min value. Okay, so what do we have to do here? So we know that our x length is 30. So let's go back and we will find our y value, okay? So we set up here y is equal to 1,800 divided by x. And our x is 30, so 1,800 divided by 30 gives us a y value equal to 60. Okay, these units are in meters, so include your units here, and x is equal to 30 meters. All right, so this next one here, we are finding the volume of the largest circular cone that can be inscribed in the sphere with a radius of 30 centimeters. So sphere with a radius of 30 centimeters means that to any point in the center of that sphere, it is 30 centimeters to get there, right? All right. Hopefully my drawing is going to be okay here. Okay, so we have 30 centimeters as our radius. Okay, we want to fit a cone inside of this sphere. Okay, so again, bear with my drawing skills here, please. So there is the base of the cone, and we want to find the maximum cone. There's our cone. Actually looks pretty good. And the height of the cone, so from the very base to the top, is going to be my h. Now, remember the radius. So the point from the center of the cone, the center of the sphere to any point in the circle is 30 centimeters, right? So I know that this whole, like right up here, is 30 as well. Okay, and then this area in here, that little red area, that is going to be the height minus the radius. Okay, so it's going to be h minus 30. H minus 30. Okay. Now we know h minus 30, and there's one last component that we need to find here is the radius of the cone at the bottom. Okay, we are looking for the radius of the cone. We know the radius of the sphere, the cone is inside, okay, but we still need to find the radius of the cone. Okay, so we have a little bit of information here. Now, one thing I should mention right now, so volume of a cone is equal to 1/3 pi r squared times the height. Okay, and don't worry too much about that formula. You guys will get a formula sheet with a bunch of volumes and stuff on it. Okay, so excuse me. So I want us to focus in on this small triangle that is part of the cone, but also part of the sphere. Okay, so we have radius r at the bottom. We have a hypotenuse, which is the radius of our sphere, which is 30. And the height within that cone, that little red area, is going to be h minus 30. Okay, so the height is the whole height of the cone, and that's going to be subtracted from the radius of that. Okay, so right here we have a right triangle. And remember, we're trying to put this in terms of either r or h. Okay, so we're going to use the Pythagorean theorem here. A squared plus b squared is equal to c squared. Right? Now, I want us to recognize this r squared up here, right? When we are applying the Pythagorean theorem to our smaller triangle down here, we can actually just simplify the Pythagorean theorem in terms of r squared and then substitute that into our volume formula. Okay, so I'll show you what I mean. Okay, so my hypotenuse is 30. So 30 squared is equal to r squared plus h minus 30 squared. Okay, note that we have r squared here and we have r squared up there. So let's write this formula in terms of r squared. Okay, so we will subtract h minus 30 squared from both sides. Then we'll be left with r squared is equal to 30 squared minus h minus 30 squared. So let's simplify this a little bit. So 30 squared is 900. And we can expand to h minus 30, h minus 30. So we do that, we will have 900 minus h squared minus 60h plus 900. You can go ahead and distribute that negative in there. So it's equal to 900 negative h squared plus 60h minus 900. Those cancel. And then we are left with r squared is equal to negative h squared plus 60h. Okay, so now that we've written that in terms of r squared, we can substitute that into our volume formula, okay? So r squared is equal to h squared plus 60h. So volume is equal to 1 over 3 pi times r squared, which is negative h squared plus 60h multiplied by h. Okay, so let's distribute that h into the brackets, and let's just leave the 1 over 3 pi alone, okay? We're just gonna let that hang out for the next little bit. Okay, so we get volume is equal to 1 over 3 pi times negative h cubed plus 60h squared. Okay, so let's go ahead and take the derivative of this, so v prime. And again, we're only going to take the derivative of what is inside of the brackets, okay? So leave 1 over 3 pi alone, and then we're going to have negative 3h squared plus 120h is our first derivative. Let's go ahead and find our second derivative as well. So v double prime. And again, we're going to leave the 1/3 pi alone. And the derivative of negative 3h squared is negative 6h plus 120. Okay, so let's find the critical values for our first derivative. Okay, so 0 is equal to 1/3 pi times negative 3h squared plus 120h. Okay, if we divide by 0, or right, so let's get rid of 1/3 pi. Those cancel. And 0 divided by 1/3 pi is 0. So 0 is equal to negative 3h squared plus 120h. Can factor out an h. Negative 3h plus 120. Okay, divided by h. We'll be left with 0 is equal to negative 3h plus 120. Solve for h, subtract 120 from each side. Divide by negative 3. H is equal to 40. Okay, so what we have just found is the height of the cone that can fit in there. So this whole h here up at the top is 40. And then if you subtract 30 from 40, that will tell you the height of this right angle inscribed in that cone. Okay, so we know we have a max min point where h is equal to 40. So let's put that into our second derivative just to confirm that this is a maximum function. Negative 6 times 40 plus 120. And negative 6 times 40 is negative 240 plus 120, still a negative number. So v double prime is a negative answer. Therefore, this is indeed a max function. All right. So we know our h is 40. So let's go and solve our dimensions now. Okay, so if we go back to our r squared is equal to negative h squared plus 60h. We can solve for our r because we know our h value, right? So this is equal to, and we may as well, we can leave this in terms of r squared because again, when we're going back to find the max volume, the equation already has r squared in it. So we can kind of leave that alone for the meantime. Okay, so r squared is equal to negative, so negative 40 squared plus 60 times 40. Okay, so r squared will equal 800. So now we can substitute our R squared value into our volume formula. Okay, so volume formula, volume is equal to 1/3 pi R squared H. Okay, we know our H, and now we know our R squared, so let's go ahead and find our max volume. So R squared is 800, and my height is 40. Okay, so punch these into your calculator, and you'll get a volume of 33,510 centimeters to the 3, right? Volume is in 3 dimensions there. All right. So your homework is to try one of each of these questions. And yeah, you can just do like the ones where we have gone over it in class. If you're looking for a little bit of a challenge, feel free to go ahead and try some of those that we didn't go over in these video lessons. Okay. But yeah, so if you have any questions or need help with anything, please don't hesitate to ask. And I hope you enjoy the rest of your day.